Hello guys, today we are going to start with the concept of linear acceleration in circular motion. What is linear acceleration, by the way? It is the rate of change of linear velocity with respect to time. Let us see what is linear velocity. In the previous lecture we have studied that the linear velocity v bar is omega cross r. We want to study the rate of change of linear velocity. Let us differentiate this. Let us differentiate both the equations with respect to time, both the sides with respect to time. So therefore you will get dv bar by dt equals d by dt of omega cross r. What is dv bar by dt? It is linear acceleration, a bar. And here you have two functions. So when you have to differentiate two functions which are product of each other, you will use UV rule, which states that first you differentiate one of them and then you differentiate the other in a particular order. So therefore you will get a bar equals, what is d omega bar by dt? It is alpha bar, change in angular velocity with respect to time. The change in radius vector with respect to time or the position vector with respect to time will give you linear velocity. Now the linear acceleration consists of two parts, which is alpha cross r and omega cross v. One of them is in the tangential direction and the other is in the radial direction towards the center, radially inward. Let us try to understand it, how it is. Consider an object which is performing circular motion. The object is here, it is moving in anti-clockwise direction, the direction of velocity is here. Now the direction of radius vector is here. What is the direction of alpha? Let me try to explain. The direction of alpha is here if omega is increasing, because if omega is increasing then alpha is parallel to omega. So the direction of alpha according to right hand rule, if the object is moving anti-clockwise, is here, and the direction of v, so direction of r is here. So if you take alpha cross r, which is here, you will get the direction of v, means the component of linear acceleration which is in the tangential direction is this, at bar. Now let us see the other component, which is omega cross v. Where is the direction of omega? Omega is here. Where is v? V is here. So omega and v should be, we have to take the cross product of both of them, omega cross v. Omega cross v gives you radial direction, radially inwards. So the direction of the other component of linear acceleration is radially inwards. We call it as radial acceleration or we call it as centripetal acceleration. Why? Because it is towards the center. And hence you have two parts here. One is tangential acceleration at bar, the other is radial acceleration AC bar. And both of them are perpendicular to each other, you can see. So therefore, linear acceleration consists of two parts. One is tangential acceleration, the other is centripetal acceleration. What is the difference between both of them? This is in the direction of tangent and that is radially inward. Again, the formula of at bar is alpha cross r. And you know that alpha and r are perpendicular to each other. Since alpha is perpendicular to r, therefore alpha cross r would become alpha r sin 90, which gives you alpha r. So magnitude wise at is alpha r. And you can see if alpha is 0, at becomes 0. It means that in a UCM, in a uniform circular motion where the object has a constant speed of rotation, the object has a constant speed of revolution, the object has constant omega, in that type of motion alpha is 0 because there would be no acceleration, angular acceleration, and therefore at would be 0, tangential acceleration would be 0. Let us talk about centripetal acceleration. Centripetal acceleration is omega cross v, and again we know that omega and v are perpendicular to each other. So since omega is perpendicular to v, therefore AC would become omega v sine 90, which gives you omega v. From the previous lectures you know that v is r omega. So this becomes r omega square or omega square r. So centripetal acceleration is omega square r. And this type of acceleration or this type of linear acceleration is present even if the object is in UCM, it is present. It means that if the object is moving with constant angular speed, centripetal acceleration will always be present. It would be constant in that case, because if omega is constant, AC will be constant. If you want to write it in vector form, AC bar would become minus omega square r bar, because the direction of r bar is radially outwards and the direction of AC bar is radially inward. They both are opposite vectors, and hence we have to put a minus sign. So to conclude, circular motion is basically classified into two categories. One is UCM, the other is non-UCM. In UCM you have omega as constant. In non-UCM, omega changes, omega varies with time, it directly depends upon, somehow depends on time, it changes with time. So in UCM what happens is, AT, you have two types of, only one type of linear acceleration, which is AC, because AT is 0 and AC is omega square r, and the total linear acceleration is only AC. In non-UCM, AT is present and it is r alpha. AC is also present, which is omega square r, and therefore A, which is the total linear acceleration, it would be the vector sum of AC and AT. Since both of them are perpendicular, therefore you have to take under root of AC square plus AT square, because if two vectors are perpendicular, by parallelogram law the vector sum is given by under root of A square plus B square. You know it from your vector classes. Thank you.